Hi guys. So the next lesson that we are going to be working on, we're still going to be talking about trig, but before we get a little bit more into it, we need to talk about degrees and radians. So we're used to thinking of things in degrees, right? Like 90 degrees, we can visualize what that is, 30 degrees, 180 degrees, and so forth. But in pre-cal, we also use what we call radians. So we need to know how to convert back and forth between the two. Okay, so the formula that we can use to hold on, trying to move this out of the way. Okay. Okay, there you go. So the formula that we can use to convert back and forth between radians and degrees is that 1 radian equals 180 degrees. You need to write that down somewhere in your notes. You should be taking notes right now, okay? So 1 pi radian equals 180 degrees. Okay, 1 pi radian equals 180 degrees. So we can use that to help us convert easily back and forth between one another. So if we want to convert from degrees to radian, so we would start with degrees and end with radian, we are going to use this right here. So to convert from degrees to radian, we are going to multiply our given degree by pi over 180. And we'll do a couple of examples in a second. Okay, but you need to write this down in your notes. To convert from degrees to radians, we multiply our given degree by pi over 180. Okay. So now, when we want to go the other way, the opposite direction, when we want to go, make sure that you pause it if I'm like going too fast. Pause, write down what you need to write down, and then push play. Okay, so when you want to go the other direction, when you start with radians and you need to end at degrees, we use this equation instead. So kind of similar, except the numerator and denominator, as you can see, they kind of swap places, okay? So when we want to convert from radians to degrees, we multiply our given radian by 180 over pi. So we would multiply our given radian by 180 over pi. And again, we're going to do a couple of examples right now in just a sec. All right, so let's start our examples. Okay, so example 1. We are converting 200 degrees to radians. We're starting with degrees and we're ending with radians, okay? So that means we're using this first method up here. We start with degrees, end with radians. So we're going to need to multiply what we're given. Multiply it by pi over 180 degrees. And that's what you should have already copied up at the top. Okay, so we multiply our given by pi over 180. Okay, so we end up with 200 degrees pi. Actually, the degrees are going to cancel out. Our units are going to cancel. But 200 divided by 180, I can technically simplify that and make that into a smaller fraction, right? Just like 2/4 equals 1/2. So if I'm going to simplify that and make it into a smaller fraction, that actually is going to become 10 over 9 pi. So 200 degrees equals to 10 over 9 pi, or 10 pi over 9. Okay, that's how we're going to convert from degrees to radians. So let's do another example. So same concept, we're starting with degrees and ending with radians. So we're going to use this same equation right there. So I'm going to multiply my given degrees times pi over 180. That's going to end up giving me 120 pi over 180. But again, knowing that we can simplify that fraction into a much, much smaller fraction, which is going to become 2/3 pi. So 120 degrees is equal to 2/3 pi. Okay. Hopefully you're getting the hang of it. Make sure that you're reaching out to me on Reminds if you're a little bit confused about something specific. All right, so now we're doing the other way around, okay? I just don't know how to spell. Okay, so the reason why I know we're doing the other way around is because they're giving us radians, and now we're ending with degrees, okay? Seriously, why can't I spell? I don't know. Okay, just kidding. So I'm starting with radians and ending with degrees. So that means I'm using this equation right here. Starting with radians, ending with degrees. I'm going to multiply by 180 over pi. So I'm going to multiply by 180 over pi. So let's go ahead and start that process. Times 180 over pi. Okay, and because I do this, this allows the pi's to sort of cancel each other out. Okay, so they cancel each other out, which means when I multiply 4 times 180 and then divide it by 9, I end up with whatever degree I end up with. So you can probably use just some scratch paper and figure out what that math is. So 4 times 180 divided by 9 will give me my degrees, and that is 80 degrees. Let me do that a little better. Okay, 80 degrees. So 4 over 9 pi is equal to 80 degrees, all right? And then that's the same method you would use every single time you want to convert radians to degrees. So let's look at example 4. Okay, so example 4, this time we don't have a pi to cancel, but that's okay. So 1.4 radians, this is what we're starting with. And we're ending with degrees. We are still going to multiply by 180 over pi. But this time I'm just going to put this like entire piece into the calculator. Okay, so I have my calculator here next to me. Let me go ahead and figure out what that is. So I have 1.4. Where's the decimal? Actually, okay, 1.4 times 180 divided by pi. Sorry, I don't know why it's taking me so long to put this in the calculator. I can't find pi. Oh, there it is. Okay, so I multiplied and I got 252 divided by pi, which gives me 80.21. Okay, so because our pi's didn't cancel out, because they gave me a decimal value, that just means that I'm going to have a decimal value for my degrees. Okay, if I have a situation like example 3 where my pi's will cancel, then more than likely I'll end up with a nice whole number just like we did. But if I have a situation like example 4 where I don't have an extra pi that's going to cancel, that's okay. I'm just going to plug it into the calculator and it is going to give me a decimal value as my degree. Okay, so you are going to practice doing that. Okay, so you have a couple of questions right here that you're going to practice in just a second. You have 10 questions, okay, so you can practice converting. Make sure that you're paying attention to, are you going from degrees to radians, or are you going from radians to degrees, okay? Anytime it has this little symbol at the top, that implies that you're starting with degrees. Everything else will mean that you are starting with radians, okay? All right, so you're probably going to do this in a time to climb, so those slides are timed, okay? Make sure that you're not just sitting there staring at the question for like too long, because then you're gonna run out of time. So when you complete this, make sure that you're ready with a calculator and a scratch sheet of paper so you can be prepared to answer these questions, okay? All right, so the next thing that we are going to learn how to do is how to find angle measurements here on a coordinate plane. Okay, this is going to start introducing us to eventually talking about the unit circle, but for now we're just going to look at a coordinate plane. Okay, so what this says is if you are going counterclockwise, your degrees, or radians for that matter, will be positive. Okay, so since this arrow is going counterclockwise in this direction, that will give me positive angle measurements. Now, vice versa, if you are going clockwise, then your angle measurements are negative. So if you go in this direction, well, that was really messed up. Okay, if you go in this direction, I still can't. Okay, it's a good thing I'm not an art teacher because I don't even know how to do a semicircle. Okay, so if you go in that direction, that will be considered negative angle measurements. Okay. All right, so let's talk a little bit about this coordinate plane, which we should kind of be familiar with, right? Maybe not the whole circle thing, but back in Algebra 1 or even in Algebra 2 or even anytime you graph things, you are familiar with this coordinate plane. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, again, make sure that you're pausing and taking your notes if I'm going a little bit too fast. Okay, so each quadrant has 90 degrees in it, or in other words, pi over 2, if we're talking about radians. Okay, each quadrant has 90 degrees within it. So this is 90 degrees. Okay, I'm going to do this other one in a different color. If I go 2 quadrants, that means I've gone 90 plus 90 is 180 degrees. Okay, let's do a different color. If I go 3 quadrants, that's 90 plus 90 plus 90, so that's 270 degrees. Okay, and if I complete an entire circle, if I start here and go all the way around, man, my circle, that was a messed up circle. Then I've completed 360 degrees. Now, because I'm going counterclockwise, these would all be positive. Okay, the same situation would happen if I was going in a negative direction, this would be negative 90 degrees. And then the same situation would happen if I was going in the opposite direction. Okay. All right, so that's talking about quadrant. So now that we know that tidbit of information, let's do some examples where we have to find measurements on this coordinate plane. Okay, let's look at our first example here. So, they want me to figure out what this complete angle measurement is. Okay, well, based off what we just finished talking about, this quadrant right here, this piece, we know is 90, because we just finished talking about how each quadrant is 90 degrees. But this extra little piece right here on the side, they told me is 55. So if I want to get that entire length, all I need to do is add 90 degrees plus 55 degrees, and that will give me my total angle measurement. So quadrant 1 plus 55 more gives me my total measurement of 145 degrees. So that means this whole piece right here is 145 degrees. Okay, let's look at example 2. There's actually a couple of different graphs here. So let's look at this first one up here at the top. Okay, so for this first angle, I don't even make it all the way to quadrant 1. I'm stopping right there. This is where my angle measurement stops. And they are telling me that that's only 52 degrees. So I don't really have to do anything for this particular one. I only go 52 degrees. I didn't even make it to one whole quadrant. All right, let's look at this next question over here. So based off what we said, I need to find this whole angle measurement. Stopping here. I don't know if you can see, maybe if I erase it, you can see the direction of the arrow is pointing this way. That means my answer should be negative. I'm going clockwise now, right? So I need to find this entire angle measurement, knowing that this part is 90, and then I go a little bit more, I go 45 more, keeping in mind that my answer should be negative. So I'm really just adding 90 plus 45, knowing that my answer is negative. So if I add 90 plus 45, I should get 135. Well, actually negative 135, because I'm going counterclockwise. I'm sorry, I'm going clockwise. Okay, one more. All right, look at this one. This one's a little bit different. Not different, but okay. So let's take a look at, first of all, the direction. All right, so I know I'm going positive, all right? So I already know that. Now, let's see. We start here. We go all the way around. If we go all the way around, that's already 360 degrees. Plus, we went a little bit more. We went 20 more. So 360 plus the 20 gives me a total of 380 degrees. Okay, you're going to do some examples here. That way you can practice that skill. Again, this will be in the time to climb. Make sure that you please snap a picture. If you're doing it on your phone, take a screenshot. If you're doing it on your laptop, take a quick picture of your laptop once you've completed the time to climb, because that's what you're going to be submitting to me on Schoology. You're going to take a picture of your time to climb, submit that on Schoology, okay? Reach out to me if you guys have any questions.